The sample class that I'm going to use for most of my discussions about properties and methods is a customer class. This represents a company that's a customer. And the class has a number of properties, each of which provide one piece of information about the customer. There's a customer ID. This is a string representing a 5-character ID for the customer. The property is read-write so that new customers can be created by code. Then there's a customer name property. This is a string representing the name of the customer. It's also read-write. City, a string representing the city where the customer is located, also read-write. Region, a string representing the region where the customer is located. Usually this is going to be a state or a province or a territory or something like that, whatever is appropriate for the country. And it's also read-write. Postal code. This is a string representing the postal code of the city where the customer is located. In the United States, it'll be the zip code. And that property is read-write. Country, representing the country. And it's also read-write. And what's interesting about this property is that it has a default value of USA. Since most of our customers for this fictitious company, whatever company it is in the United States. And then there's annual sales. This is an integer representing the company's annual sales in dollars. It's read-only. Presumably the number is retrieved from some kind of sales database. But here I'm going to simulate it so that we can keep the customer class code simpler, because I really want to focus on defining the details and members of a class rather than database access and so forth. That's a topic for another day. And finally, there's a location property. This is another string representing the city, region, and postal code, all concatenated together, presumably for doing something like printing address labels. And this property is read-only. Here's the code for the customer class that I'll be using to talk about properties. So it's the namespace props methods. That's the name of the solution. I left that as the default namespace. Class definition, class customer. And then it defines the various members of the class. So let's start talking about properties. Here's the property that defines customer name. So this is where the name of the customer is going to be stored. It's public, so this is accessible from outside of the class. It's a string type. It can be any data type, any built-in data type, or any custom classes that we want to build, whatever. And then we define it using this get and set notation. So these define the different methods that are executed when external code either reads from or writes to the customer name. So in the case of the getter, it's going to return the value of underscore customer name. And in the case of the setter, when external code sets a value to the property, it's going to get the value from that value keyword and assign it to this backing field. Okay, so this field here, underscore customer name, is defined up here at the top of the class. So this is a private field, has a private keyword, which means that this code is not directly accessible from code outside of the class. It's only accessible within the class. So only the members of this class can access underscore customer name. Now, this is sometimes called a backing field. And so this is where this particular class is going to store the actual name of the customer when external code writes a value to the customer. Okay, so when you make a change to this property in your external code, you pass new information to the method via the value variable. So if I come back down here to the customer name property, I'm assigning a value to customer name from external code. That is represented, essentially is manifested here within the property within that value keyword. And this is a set keyword. You always have to use value. That's why it's blue, because it's a keyword within C#. And that updates this backing field. So this is just a regular variable that is a memory location that stores the data. Happens to be a value type, but it could also be a reference type. And then when you later query the value of the property in your code, then the getter method reads the value of customer name that's stored in that variable and returns it to the calling code. So because I have both a getter and a setter method. Customer name is a read-write property, and it uses the customer name backing field to store the current value of the property. Now, and one thing about backing fields, prefacing the name with underscores, as generally I do in this course, is by no means necessary. There's nothing magical about that convention whatsoever. It's how you use the variable that makes it a backing field. It's not a naming convention. Nevertheless, using an underscore is a useful convention so that you can name the field the same as the property it backs. That makes it very easy to know that underscore customer name is the backing field for the property customer name. You could also use all lower and uppercase as well, such as lowercase customer name as the name of the backing field, because of course case matters in C#. But it's a best practice to name the fields nearly the same as the corresponding properties. Just makes it easier to look at the code and see what's going on. Okay, so again, this is a read-write property because I have both a getter and a setter method. And getters and setters are implemented using the get and set keyword as I have here. Get method executes when the code reads the value of the property, it gets the value of that property, and returns it to the external code. And the set method executes when the code writes the value of the property. And so to make a property read-only or write-only, you can omit either the getter or the setter method. Can't omit both because then you don't have a property. Can't do anything. But you can omit either one in order to restrict what external code can do with that property. Another thing about getters and setters is that in the sample code here, at least for customer name, there's only a single statement for each of the getter and setters. But this is a full code block. You could have thousands of lines of code that execute when you get the value of that property. There's basically no restriction. So you have free reign of the code that you write in order to implement the features of the property. And one example is that a setter method will often have multiple lines of code to validate the new property value, such as to do a lookup against a database. Now, how I wrote customer name, the property here, I made liberal use of whitespace, and generally whitespace is great. Doesn't affect the compiled application. The C# compiler essentially strips it all out. But you can tighten up the code to save space if you prefer, maybe even save a few keystrokes. So for example, I wrote the city property this way. So compare the two properties. Lots of white space, carriage return line feeds, basically one element per line, lots of tabs, and so forth. But there's nothing magical about that white space. It doesn't do anything. It has no meaning in C# in this context. And so have city like this. I have the getter and the setter on a single line each. But I could even tighten it up further. I could get rid of this carriage return in that tab, and that carriage return in those tabs, and that carriage return in that, and put all of that on one line. And that's what I did here. So this is perfectly valid. I named it a different name, property name, so that I didn't even get a compiler error that I had duplicate properties, which I would if I tried to define the same property twice. But notice that the only white space that I have included here is necessary white space. I have to have a white space to distinguish those two keywords between that and the property name. I don't need any white space adjacent to brackets because the C# compiler knows that a bracket is a particular kind of delimiter. I do need a space here to separate those two strings, the keyword from the variable name. No white space, and then, well, in fact, I don't even need this white space right there. So I can tighten it up even a little bit further. So that's a pretty minimal property definition, but I strongly urge you not to write code like this because this is still pretty readable. This is eminently readable. You can scan down through code and see very quickly what's going on, although it's pretty, not verbose, but it's and not wasteful, but it definitely takes up a fair number of lines of code within your file. This is still pretty readable. You can still scan it pretty well once you're used to the property notation, but this gets really hard to read. So I really strongly urge you not to write code quite that terse. As usual, just because you can do something in C# doesn't mean that you should do something in C#. Okay, so I'll get rid of that statement. So again, writing code like this is just going to make your code much less readable and maintainable. Okay, so I'm going to come back over to my program.cs. And here's some very simple code that exercises that class. So I new up the class. Customer name is an instance method, so I need an instance of the object in memory in order to access it. So I new it up. I set the property name, or the property value, to learn now. Okay, so this is going to execute the setter method that I just showed you. And then I display it out to the console, and I'm going to read the property, and that's going to execute the getter method that I showed you. All right, and just to demonstrate that this works, I'll go ahead and run the application. And once it starts, I'll hit A, and you can see that I've created a class, set its property name to learn now, and I've read it out and displaying it on the console. Okay, so cool, our code works, and more importantly, the class works. Okay, I'm going to come back over to customer, and I want to make one note about how I've implemented properties. Strictly speaking, you don't have to implement properties like this. You can just declare public variables at the class level. So for example, for the customer name here, instead of making this a private field and then defining a public property, as I just showed you, I could make this a public field. So in essence, what this does is this makes underscore customer name a property of the class. But then I can't write any code to, for example, validate new values or calculate the value of properties. The only restriction would be that the new value has to be of the correct data type, in this case a string, or if I define it as an integer, a double, whatever it might be. I strongly recommend that you resist the urge to use public fields like this. And as you learn more about implementing properties, you should begin to better understand why. You just have a lot more flexibility, have a lot more control, and you're then really hooking into the features of C# that support robust properties within your classes. Okay, so I'm going to undo that change. All right, now the customer name property is just reading and writing a value to and from a variable. So pretty simple code, just working with that backing code. But you're not limited to just reading and writing values to variables like this. You can write whatever code you need to in a property to determine the value for the property. So for example, let's take a look at the location property. And it's real easy, by the way, to navigate around a class. Notice that there's an awful lot of members in this class, and I can scroll all day, and you'll get all bored with my scrolling. But I can just go directly to the property that I want. Okay, so this shows a different way of defining a property. So this is the location property. And it's going to return a string that concatenates together the city, the region, and the postal code. And so presumably this is something that a property that makes it really easy to use that address information in an address label or in a report to identify general demographic data. The first important thing to notice about this property is that it's read-only. I've only implemented the getter method here. There's no setter method, so there's no way for external code to write a value to the location property. If I attempt to do that in my external code, I'll get a compile time error. Not a runtime error, but a compile time error that says, in essence, you can't write to a read-only property. Okay, so this is a typical pattern for a calculated property, although it's by no means required. So for example, one kind of stretch thing I could do with this is I could make this read-write. I could implement a setter method that parses out the string, validates that it has three parts that are separated by spaces, and you need to do something that handles the case where there's, say, a space in the region name or something like that, or space in the postal code, like Canadian postal codes have a space in the middle of them. So I need to handle that in the code, but then I could assign a string of the proper format to the location property and it would shred the string and assign the values to the individual backing fields. So that is certainly possible. All right, so when I read the value of location, it's executing the string.format. And I did say concatenate before. Strictly speaking, it's not concatenating them, but that's the essence of what it's doing. It's actually formatting the string using string interpolation, plugging in the current values of underscore city, underscore region, and underscore postal code. And by the way, in a method like this, I don't need to use the backing fields, particularly if there is code in the getter methods of the properties that should execute for whatever reason. Instead of directly reading the backing field, I could read the property instead. So now this is reading the property instead of the backing field. And I could do the same thing for region and postal code. So in fact, that's probably a slightly more common way of doing it. Again, just to make sure that any code within the getter method that should execute, if it's not just a return statement, it'll execute when you read that data. Maybe you need to log the number of times that the city property is read, or it itself is some sort of calculated field that needs to be recalculated. In that case, I probably wouldn't be using a backing field, but maybe for performance reasons, I do use a backing field to make it more efficient. But I really shouldn't be reading directly from it. So in that case, I would want to read from the city property. All right, so if I come back over here to program, I can look at this calculated property value method here. And so what this code does is it news up a customer, sets a few properties, the customer name, city, region, and postal code. And then it's going to read the individual values there of various properties. So customer name is a direct value, read directly from the backing field. It's going to display the location, which is that calculated field that I just showed you. And then it also reads the country. Now, keep in mind that I'm not setting the country in this code. So just keep that in the back of your mind for the moment. And then I do the same thing again, basically. I new up a new customer. I'm going to assign this new object instance to the same variable. So this company is going to be released from memory. The reference is going to be released, and the garbage collector can then go through and actually release it from memory. I'm setting the customer name, and then I'm reading the customer name, and I'm reading the annual sales. And I'll talk more about this shortly. Okay, so I'll press F5. We're in the application again. Select B this time. And here's that first set of code. And as you can see, it produced, reading the location property, produced that line of code right there. All right, and notice that country is set to USA. And I'll talk more about that a little bit later, about how that happens within the code. All right, so let's look at another example of this. Now, the location property's value is based on the values of other properties in the customer class. But sometimes you need to work with entities outside the class to determine the value of a property. And a good example of that is the annual sales property. So there's the definition of that. All right, so this is obviously contrived. What I'm doing here is I'm simulating getting this company's annual sales from someplace else. Generally, I'm probably going to execute a query against some tables in a relational database, looks at all the orders and aggregates them all together and comes up with an annual sales, presumably for the current year or the previous year, or whatever the code happens to do. The idea here is that the sales figure for a customer is not stored in the customer class. And so again, I'd probably hit a database, but I'm just simulating it by generating a random number. And so this is going to generate some wildly varying numbers for annual sales, but that's okay. I just want to return, in this case, an integer. And so now the getter consists of two statements. So first demonstration that you can actually have multiple statements within a getter or a setter. You're not limited to just a single statement. And it doesn't make use of a backing field within the class. Again, to demonstrate, Backing fields are useful. There's a lot of properties that makes great sense to implement that way, but it's not a necessary part of defining properties. So again, this shows that you can do just about anything you want in the code of a property's methods, the getter and setter methods. Okay, if I come back over the code, that's the rest of this method here. So I'm creating a new customer, and I'm reading the customer name, and then I'm reading the annual sales. I'm not doing anything to set the annual sales or anything, because this is a calculated value that is generated on the fly. Happens to be a random number, not generally how you're going to want to represent a company's sales, but it works to show how you can create calculated values using whatever code you want. And if I once again run this and hit B, you can see that the sales are basically $2,073,000,000. If I execute it again, now it's $371,063,811. Just generating random numbers. So, don't get stuck in the rut of thinking that the properties of a class are simple read-write operations using a backing field. The code that implements the getter and setter methods of a property can be as simple or complex as you need. You should always go for simple, but don't let that limit what your properties can do. Okay, so now let's talk about another aspect of defining properties on a class. Once again, the customer name property is about as simple as it gets. Come back up here, just using a backing field, reading and writing the values. There's no additional processing that's required. Pretty much as long as the calling code passes a string, or something that C# can reasonably consider a string, this code is going to execute just fine. It's going to store the string, retrieve the string, and so forth. But as I've said, you can put as much code as you need in a property to work with the value passed by calling code. For example, you may want the customer ID property to be all uppercase. So what you can do is here within the setter method, you can take that value that's returned, that's being assigned to the customer ID, and convert it to uppercase. And so that way, from now on, that customer ID value within this class is always going to be uppercase. Okay, so that's converting the value. And then you can also validate the value that's passed to the property. And that's what happens in the country property here. So the example here is that maybe for now you only sell to North American customers. And so you want to limit the country property to USA, Canada, or Mexico. And this is how you can do that. Within the setter, you can check to see if the value that's being passed in is contained within this string. Another better way to say that is see if this string contains value. If it doesn't, then it's not USA, Canada, or Mexico. Now, this isn't a real robust way of doing that, because one of the things the calling code could do is pass literally that string. And the if expression here is going to return true, and it's going to be assigned that value. Clearly, that's not a valid country name. But in a real application where I need to make sure the country is robust, I would either have code that validates it against a specific list, probably implemented as an array, or some other kind of collection object within C# or .NET. Or I'd hit a database or do something else to do that more robustly. Because another problem this has is that I could also pass that as the string into the property. And the string contains that, not a star Mexi. And so clearly that's not a valid country. So this is not a real robust way of doing it. My point is just to show you that you can do basic validation and throw an exception or do whatever it is that makes sense for your application that says the country must be USA, Canada, or Mexico. Okay, then if I come back over here to program, I have some code that again news up the customer, sets the customer ID. This is going to be made all uppercase. Customer name, city, region, postal code, and tempting to set the country to unknown. And then it writes out the information. It reads the customer ID. If this succeeds, it'll be in uppercase. Reads the customer name, the location, and the country. So I'll go ahead and execute that. Keep in mind I'm attempting to set it to unknown. I'll hit C. And as you see, I get an exception. Because unknown, the literal string unknown, is not contained within that string. And so it throws this exception. And this would be an exception that in a real application you would need to catch within your code and then let the user probably put a red asterisk next to the field on an input form and say it has to be USA, Canada, Mexico, or maybe a better way of doing it is to implement that as a drop-down list, whatever makes sense for your application. And again, because my application is running in Visual Studio and I didn't implement any exception handling code, it just stops here like this. And if I was running this executable, it would display something within the console window. But typically you would handle this exception within your code.